Some problems in science involve extremely small items, or measurements. These items or measurements will typically be given a scientific notation. Numbers that small are nearly incomprehensible, but they are still very useful, particularly if we try to scale them up to a more practical or useful amount. So let's look at some examples and see what that means. The mass of one bacterium is 3.2 times 10 to the negative 15 grams. That's pretty small. Now what if we want to know the total mass of 8 million bacteria? The question wants us to express it in scientific notation, which means it's probably a little bit easier to write than adding a whole bunch of zeros to it. So first thing we're going to do is we're going to make sure they're both in the same form. So since this is in scientific notation, we want the answer in scientific notation. Let's make the 8 million in scientific notation. Let's all make it the same. So 3.2 times 10 to the negative 15. And then we're going to take the decimal place here for 8 million, and we're going to move over 1, 2, 3, 4, 5, 6 spots. So 8 times 10 to the positive 6, because we moved it over from the right. And now we're going to do the 3.2 times the 8. So 3.2 times 8 times 10, because they both are times 10, so we just need a single 10. And then negative 15 and 6. We're going to add them together since they're both on one line. There's no fraction here. So negative 15 plus 6. And now we just do the arithmetic. 3.2 times 8, which is going to give me 25.6 times 10. And then negative 15 plus 6 is going to give me a negative 9. Now this is good, but not correct because it's not in scientific notation. This 25.6 is not between 1 and 10. So we're going to need to move the decimal place over one spot to the left. So we're going to get 2.56 times 10. And since we moved it one spot to the left, we're going to change this as well. So this is going to go from a negative 9 to a negative 8 since we moved it over one spot to the left. And this is 2.56 times 10 to the negative 8 grams. So do not forget the unit of measure, because you won't know what the number represents unless you have the unit of measure that goes with it. So 2.56 times 10 to the negative 8 grams. That's the total mass of 8 million bacteria. Let's do another example. The charge of one electron is approximately 1.6 times 10 to the negative 19 coulombs. I think that's how you pronounce it. What is the total charge of 5 trillion electrons? Again, we're going to express our answer in scientific notation, and if you're curious to know, a coulomb is a standard unit of an electrical charge. So we're going to start off with our 1.6 times 10 to the negative 19th. And we're going to convert 5 trillion into scientific notation. So if you're not sure, write it all out, and then move the decimal place over however many spots from the right to the left to get the total number of spots you'd have for the exponent. If you write it out, you're going to end up with 5 times 10 to the positive 12th power. And so now we just do the 1.6 times 5. So 1.6 times 5 times 10 to the negative 19th plus 12, because again, they're all on the top. There is no fraction, so there's no denominator. And now we do 1.6 times 5, which will give us a very nice 8 times 10, and then negative 19 plus 12 is negative 7. And we do not forget, or at the end, the unit of measure, coulombs, if that's the correct way to pronounce it. So what is the total charge of 5 trillion electrons? 8 times 10 to the negative 7th coulombs. Let's do one more. A single red blood cell has the volume of approximately 1.4 times 10 to the negative 13 liters. What is the total volume of 2,500,000,000 red blood cells? Again, express our answer in scientific notation. So 1.4 times 10 to the negative 13th. And we're going to move this the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So 2.5 times 10 to the 9. And just like before, the 1.4 times the 2.5 go together, times 10, and then negative 13 and positive 9, like so. And then 1.4 times 2.5 is going to give me 3.5 times 10, and then negative 13 plus 9 is going to give me a negative 4. And this is again in the unit measurement of liters. So what is the total volume of 2,500,000,000 red blood cells? 3.5 times 10 to the negative 4th liters.